So we've been talking about compound interest, but what if we don't want to wait until the end to pay my loan out? We've been talking about scenarios where we have a loan and the interest accrues over 2 years, for example, and then we've got this lump sum and then you pay it out. But what if, for example, we wanted to make monthly repayments instead, which is actually quite normal for loans in real life. People often make weekly or monthly or fortnightly repayments on a car loan or a house loan. And that gradually reduces the balance of the loan over time rather than just paying it out all at the end. And an interesting thing to note is that this actually tends to reduce how much interest you pay overall. So if you let it compound again and again and again and wait until the loan grows and grows and grows, and then you just choose to pay it out in one lump sum all at the end, that means you're actually probably going to end up paying a little bit more interest. Whereas if you make monthly repayments, the amount that they're charging interest on is slowly getting smaller and smaller, so you'll actually end up paying less interest overall in the long run, which is good news for a loan. So again, we can calculate reducing balance loans using recursion. So just like compound interest, we can use recursion. So what that is that's applying the same rule every time. So if you think about it conceptually, before I show you the formula, we have our initial amount, which is the money left owed on the loan, and then each time period, they're going to charge interest on that, and then we're going to make a repayment. So, and then in the next time period, they'll charge interest, and then we'll make another repayment. And how we model that using the recursive definition is this here, and you can see it. So the value of the loan after n plus 1 amounts of time periods is equal to the previous value multiplied by R, which is the rate at which it's growing, the compound interest rate, take away capital R, which is our monthly repayment amount, or our weekly repayment amount, or our yearly repayment amount, whatever like compounding kind of time period we're working with. So A0 is again the initial quantity of the loan. AN is again the amount owed after n periods. And R is equal to 1 plus I divided by M. So we're coming back to this first version of the formula that we used, where R is 1 plus the decimal rate of interest per annum divided by the number of compounds per year. And that gives us the amount the loan is growing by, So we've got those two variables to find the same. And then our capital R is the repayment being made at the end of the period. So there's our formula. So take, for example, a loan of $20,000. The initial value of this loan is $20,000, and AN is still the amount owed after n periods. And in the case of this loan, they are being charged 12% per annum, which is a lot of interest, and that's compounding monthly. So this person is going to want to pay off their loan as quickly as possible so they don't have to pay as much interest, because the longer you leave your loan, the longer you leave it unpaid, the more time that the bank or the lender has to charge you interest. So to calculate R, we've got our decimal rate of interest, which here is 0.12, so we've got 12%, and then divide it by 12 because we've got compounding monthly. And then that gives us our growth factor of 1.01. So our loan, the value of our loan is growing by 1.01 every time period because they're applying interest on it. And then we have R, which is 2,000, because that's the amount that we're paying back on our loan every month. So that's how much the value of our loan is going to reduce by. And so now we have the recursive definition. So we have AN plus 1 equals 1.01 multiplied by AN. Take 2,000 where the initial value was 20,000. And now we're going to have a look at how we would apply that formula. And another little important bit of information is that by using the recurrence relation, we can actually also work out the number of time periods required to totally pay off the loan. And also important to take note that we have rounded here. So if you did it in your calculator compared to whether you round each time, that is going to influence the final amount a little bit as well, because rounding does make a difference in our answers. So it's important to just keep track of whether you're rounding or not. So Okay, we're going to start by solving it. Let n equal 0. So you substitute into the formula a, n plus 1, 0 plus 1 equals 1.01 multiplied by a0, take 2,000. And that absolutely makes total sense, because what we're saying here is a1, so the amount after one time period, the amount after 1 month, is equal to our growth factor multiplied by the original amount. So the original amount is growing by that much, but we're also taking away $2,000 because we're paying off $2,000 of that loan. And so you can see here the effect of that. Our loan, how much we owe, has increased by $200 because that's how much interest has accrued. But then it's grown, but now it's going to shrink a little bit because we're going to pay off a little bit of it back. So the amount owed, left owing after one time period, is $18,200. So even though we've made a $2,000 repayment, it's not $18,000 left on our loan, because $200 of that has gone to paying off the $200 of interest that we've accrued. So as part of our money has gone to paying off the interest, and then the rest of the money has gone to paying off the loan. So it's interesting to note that imagine if this person had decided to make $200 repayments per month. Well, then the initial amount would grow by the factor. It'd grow to $20,200. They'd pay off $200, and then the next month the exact same thing would happen, because they would only be paying off the interest on their loan. They wouldn't actually be paying off the loan itself, which is quite a trap that some people fall into when they've taken out a large number of loans, because they might get stuck into just paying off the interest and not being able to afford to pay off any more. But that actually means that all their money is going to pay off the interest instead of actually paying off the loan. So the good news here is this person is able to make a sizable repayment every month, so that the amount they owe on their loan will actually be decreasing. So then we can apply the formula again. So amounts after 2 months will be equal to the amount after 1 month, grown by the certain factor that it's growing by. And then again, we're going to take away the $2,000 because we're making another repayment to reduce the value of the loan. And then that will bring us down to a value of $16,382. And then we're going to do the same. So after 3 months, there's $14,545 left owing on our loan. And then after 4 months, and then as we continue after 4 months, after 10 months, we've worked out all the way to, I've set a ... there because we've done the working out, but we've just skipped over it. So after 5 months, 6 months, 7 months, 8 months, and now we're up to 10 months. So after 10 months, there is $1,168.20 left owing on their loan. That is awesome news. They've almost paid it off. They're only left owing $1,168.20, which is lower than the monthly repayment. They're repaying $2,000 a month. So we know that this month is going to be the month that they're able to pay out their loan. But this is a step that quite a lot of people forget to do because it's a little bit tricky to think about it in your mind. But what we actually need to remember to do is actually apply interest to this final amount, because it's not like the bank's just going to say, oh, don't worry about paying interest on the last one. No, our formula still applies. It's still the amount A11, so the amount owing in the 11th month, is still going to be this amount here, multiplied by 1.01, and then take 2,000, except it's not going to be 2,000. It's going to be whatever the amount left owed is. So we've got to make sure that we remember to apply the interest on this final amount. So what we did here, we took that final amount, multiplied it by 1.1 to work up the last little bit of interest, and that left $1,179.88 left owing. So their final repayment, their final adjusted repayment, some questions might call it, is going to be $1,179.88. So they're not going to have to pay $2,000 in the 11th month because there's not that much left owing on the loan, which is awesome news for these people. Throughout the process, if the investment rate or repayment amount changes, we can always change the value of I, R, and R. If they said, for example, after 5 months, they changed the monthly repayments to $1,000, we could take that into account in our recurrence relation, but we didn't have to worry about that here. Because we didn't have we didn't have any changes. So it was nice and simple and straightforward. But another thing we can actually work out is how much interest did we pay. So how we can work that out is we can actually work out the total amount that was repaid, and then that will help us to find out the amount of interest that we paid back on our loan. So to work out the total amount, you would work out the total amount repaid. So to make that a little bit clearer, I'll go back to the previous slide. So we can see that up until the 10th month, we repaid $2,000 a month. So for 10 whole months, we paid back, or this person paid back $2,000 every month. So 10 months, $2,000 a month, mean they paid back $20,000. And then in the last month, they paid back $1,179.88. So we can see that the total amount they paid back was $21,179.88. And to find out the amount of interest paid, what we do is we take the amount paid back in total, which is this amount here, and take away the principal value from that. So we have $21,179.88, and we take away $20,000 from that, and that leaves us with $1,179.88. So we can actually see that that was the amount of interest paid, which makes sense, right? Because the total amount that we're paying back, part of that is paying off the loan, the money that we borrowed, but part of the money that we pay back also goes to paying off the interest. So we can see that $20,000 went back to just paying off our loan that we owed, but we can see that this amount went off to paying interest. So that's quite a lot of money in interest. And you can definitely imagine it would be even higher in the case of like house mortgages, for example. So that's how much money they paid in interest. And like I said, if you have a higher monthly repayment, you pay off your loan faster. So you actually end up paying less interest. Or if you make more frequent repayments, you also pay it off quicker. So you end up paying less interest total as well. So that's interesting to keep in mind. Oh, I think that was just what I covered. And just then. So like I said, the higher the interest rate, the longer it'll take to pay off the loan because we're being charged more interest with each compound. And also the higher the monthly repayment, or weekly, fortnightly, yearly, whatever frequency the repayment is, the shorter the time we'll spend repaying the loan, because we'll be reducing the balance quicker and we'll be charged less interest as it will be calculated off a smaller amount. And next little thing we're going to look at is when we want to calculate the monthly payment required, we actually use the annuities formula. So the formula we used back here, where's our formula? This formula here. We actually don't use this formula if we're trying to find out the monthly repayment. It doesn't work when we're trying to find out the monthly repayment. So instead, we actually use the annuities formula, which we're going to have.